So today, make sure your notes are handy. You should have your worksheet out with the problems. Remember, we had the problems 9 and 10 or 10 and 11 that we were working on. And you should have your quiz from yesterday out. What I am going to be working on is problems 10 and 11 off the quiz. And what I am going to do is I'm going to be giving you basically a step-by-step to do 10 and 11 off the worksheet. And I'm going to basically give you a step-by-step for the quiz. We're going off the worksheet first. So here's what we have on the worksheet. This is 40 feet and 18 feet tall. The length overall here is 60 feet. This was 14 feet out. Or sorry, 12 feet out. I gotta get my numbers correct. 12 feet out and 14 feet here with a 9-foot wall. We're not used to working with it like this, and the hint I had given you was to cut it. Cut this out like this and take that section out and work with that separately. So that's what we're going to do first here, is we're going to work with that section. So this is 9. From here to here is 40. Here to here is 12. And this is 18. Step 1 is to find the radius of the circle. In that circle, I'm going to cut this into 20 and 20, and this piece here is 18, right? Which would make this piece x. So that gives us the formula. 20 times 20 equals 18 times x. How do we solve for x? 20 times 20 and then divided by 18, which is 22.22. Which means we have a diameter 18 plus 22.22 is 40.22. And a radius of 20.11. I added the 18 to what I got for x. Now I'm going to pause. I want you to look at problem 1 on the quiz. Do this step. Find the diameter and radius. If you're working with somebody else, I will warn you, there are 2 different versions of the quiz, so make sure you're doing your own work. Okay, so now our next step, now that we have the radius, we need to figure out how much do we have to add to the bottom of this thing. Because we are going to have to add to it. Well, the height is currently 18. To make this a half circle, it would have to be whatever my radius is, right? So the difference between 18 and 20.11 is 2.11 feet that I have to add. Now from the center out to here has not changed. This was 20 feet from here to here plus 12 made 32. It's still 32 from the center out. So I want you to pause. I want you to do that to your drawing right now. Add whatever you need to make the total height of this equal to your radius. Okay, so has everybody got that added on to the bottom of their drawing? Figured out how much they needed to add and added it on?
Yes. Yeah.
Is there anybody that still needs a minute? The 32 is whatever half of this span was before, plus whatever the distance was here. Because it was 40 across there before, so half that's 20, right? So now our next step, we're going to divide it across here. Note that it does not necessarily go through this point. It just happened to be close to it, but it doesn't necessarily go through that. So I'm going from here, the center of my half circle, out to this corner, and I'm making this blue triangle now. Does everybody see where that blue triangle is coming from? Yep. Do you have the blue triangle in your drawing? So for mine, it's 9 plus 2.11 makes this 11.11 feet here. On the bottom here, this is the 32 feet from the center of the circle out. I am going to find three things here. I'm going to find this angle, which is the inverse tangent of 11.11 divided by 32. Which I'm getting 19.15 degrees for that angle. Now for this angle here, it's just 90 minus that, so this is 70.85 degrees. And then I'm going to find the hypotenuse up here. The hypotenuse is the square root of 32 squared plus 11.11 squared. So I've got 33, guys, you got to hold it down. You'll have plenty of time to work when I'm done here. 33.87 feet is my hypotenuse. So what I want you to do now is for your drawing, Grant, for your drawing, find those two angles and the hypotenuse. Okay? Now you can talk amongst yourselves to figure it out. I'm going to come over here and label those pieces. This is 19.15 degrees. Guys, shh. This is 33.87 feet. I'm not going to label this angle because I really don't need that angle yet. But what I'm going to do now is I'm going to look at this corner right here. One thing I forgot to copy down is that this is given as a 312 slope. Okay. So concentrating on that angle right there, that corner. So here's what we have. Now I'm going to do this. I am going to clip it across here at a 90-degree angle, which makes this angle here a heel angle. And that heel angle is found off of the 312 slope. So that angle right there is the inverse tangent of 3 over 12, otherwise known as 14.04 degrees. Which, this angle here is the inverse tangent of my slope.
Oh, so you're on the opposite side.
Yep, I'm in this yellow circle here.
Okay.
So that means that this whole angle here is 90 plus 14.04, or 104.04 degrees. Now that's not really the angle we want. What we want is this angle here. So to find that angle, this is where we go from this angle up top here. This was 70.85. From this corner of this triangle. I didn't write it in here, but we needed it up there. So 104.04 minus 70.85 is going to give me what? Yep. 33.19, does that look correct?
Yeah, but how did you get the 104? 90 plus your...
This 14.04 from here plus 90 degrees here.
Yes.
Yeah. Because this was 90 degrees plus your heel angle, yeah.
Okay, so plus the 104.
Yeah. So this is now, this angle right here is 33.19 degrees in my drawing. Yep, we're going to stop right there and let you guys find that angle. Okay, so here we go. So we've got this angle here now. Our next step, we're going to go from the center of our circle here up to this point where that roof intersects. Now we know that this angle here has to be obtuse, don't we? Because a tangent would be a right angle, and this comes in sharper than a tangent. So it's got to be a obtuse angle. So that triangle is what we're looking at now. Now I will draw it here. So it's the triangle that comes from the center of the circle up to that point of the roof, the slope of the roof over, and then back to here. This angle is the angle we just found. For my drawing, it is 33.19 degrees. This length here is the length we found from that first triangle, 33.87. That's this across here.
Wait, which one is it? Oh, it's the hypotenuse.
The hypotenuse of that first triangle, that line right there. And the other piece of information we have here is that this is the radius of our circle. So for me, that's 20.11 feet. So I'm just going to label this ABC. So this is little a, little b, little c. So now we got to use the law of sines. We have 20.11 over the sine of 33.19 equals 33.87 over the sine of angle B. Now angle B we know is obtuse, so we know there's going to be some stuff on top of this. So we are going to cross multiply and divide. So sine of 33.19 times 33.87 divided by 20.11. 0.9220. Now, that's rounded. I'm going to leave it in the calculator and do an inverse sine of that, second sine of that number. Gives me 67.22 degrees. Now, that is not my angle. How do I find my actual angle?
Subtract
180 minus the 67.22. You got it. So for me, it's going to be 112.78 degrees. So that's angle. So I want you to find that angle next. If you get that angle found, you can proceed to find this angle and this side up here. So now that we have that angle, one more minute? Okay. So to find the other angle here, this angle will be 180, guys, minus 33.19 minus 112.78. So give us 34.03 for my angle here. So that's just subtracting from 180 degrees with the angles I have. To find this missing side, then, I still have the 20.11 over the sine of 33.19 degrees equals that side C over the sine of 34.03. So that gives me that length is 20.56 feet. So I've completely solved that triangle. So I need to bring over here, I need the 20.56 feet. This, of course, is 20.11. I knew that. And this angle here is the 34.03 degrees. So now that I have that information, what else do I need to do next? Well, I need to cut this across here. Well, no, just from the center of the circle to where the original base was. Because I don't want to figure this piece. This isn't really part of anything, is it? I want to exclude that piece right here. Because this line and this line are parallel, because those are parallel, my pen won't erase for some reason, this angle and this angle are the same. So what I'm going to do is I'm going to look at this triangle right here to find that angle, which will be this angle. This triangle here, this side is half, oops, get back there. This side here is half of the original base. The original base was 40. Now, it's not the radius, it's half the original base. So for mine, that's 20 feet, half of the 40. This side here is what we had to add to our radius. So 2.11 feet for me. So again, this is half your original base. This is what you had to add to your radius. So this angle here is the inverse tangent for me of 2.11 over 20. Which gives me 6.02 degrees. So this is 6.02 degrees. Now over here, what I really want to label is this one is 6.02 degrees. So I'm going to allow you a couple of minutes to find that angle quick. Okay, so now that we have that, the reason we wanted that angle is so we can find this. So this is a half circle. So we're going to take 180 degrees. We're going to subtract that 6.02, whatever that angle is. We're going to subtract the 19.15 from over here, or whatever your angle is. Then we're going to subtract the 34.03 here, which gives us 120.8 degrees for right here. That's this angle here. I found that by just taking 180 and subtracting this angle, and this angle. Well, it's this one here, but it's also this one. And this is the one we really want it to be. So I'm guessing by now you guys have managed to punch in 180 and subtract those. Nope. Okay, we'll do it quickly.
There's way too much math, and that's one problem.
Math makes the world go round. So now we have 3 sections here. 1, 2, and 3. So what we're going to do is we're going to find the area of those 3 sections. Sure, roll here. We got to get moving. So for the shape number 1 there, shape number 1 is a right triangle. This is the 32 feet, and this is 11.11. Your dimensions obviously are different. So that area is 32 times 11.11 divided by 2. $177.6, correct? No, 177.76. This triangle is this one right here.
Oh, so now you're
finding its area, yes. There you go, 177.76. That's square feet. I'll give you a second to find your area. So it's just the base here times that height divided by 2. Same triangle you used to find this angle over here in the hypotenuse. We just found this one here, that triangle. So now for triangle 2, this one's triangle 2. We have the angle of 34.03 degrees. We have a side here of 33.87 feet and 20.11 feet. Again, you have different dimensions on your problem. So this area is side 20.11 times the other side of 33.87 times the sine of the angle between them, 34.03, divided by 2. Times the sine of the angle in between them. Divided by 2. 190.59 for mine. Square feet. Now, just so I don't have to scroll back up, I'm going to total. Yeah, screw it. We'll total it when we come back. I've got that one and this one. My third shape I need now is this sector of the circle. So I have this sector of the circle. This for me is a 20.11 foot radius, and this angle is 120.8 degrees. So that area is pi times 20.11 squared times 120.8 over 360. E pi. So I get 426.32 squared. Pi times radius squared, yep. Times the angle divided by 360. And now I'm just going to add these all up. Your numbers are a little bit different, so you guys can go ahead and start working while I add these up. So I have a total of 794.67 square feet. Let me know once you get your total and we'll go from there. Okay, so now we got to subtract out pieces. What we have so far is this whole piece right here. But our shape really only comes down to here, so we have to subtract out what's below that. So we have this triangle here. And for this drawing, this was 20, half of my original base, and the 2.11, which is what I added on to make my total radius. So that's 20 times 2.11 divided by 2, which is going to give us 21.1 square feet. It has to be subtracted out. And then we have this rectangle here that's, for this drawing, is 32 by my 2.11 that has to be subtracted out. So 32 times 2.11 divided by 2 gives me 33.76. So for mine here, again, now you can start finding those areas and subtracting, because I just have to subtract them from my total of 794 here. Yours will be different. So 794.67 for me, minus the 21.1 and minus the 33.76. I get 739.81. I'll let you guys calculate that, and we'll show you what that means here in just a minute. So the area I found here, what you should have found, is just the area of this end wall right now. If we're looking for surface here, now I'm going to do the volume first. For dealing with the volume, that's the wall, that's the end wall area, including the side of the lean-to.
But that means that you got to include backside though, right?
Oh, we'll get to that. So for volume, we're going to take that 739.81 times the length of my lean-to here, which is 14 feet in this case. don't know what happened there. There we go. So times 14, that's going to give us a volume. Again, the length of your lean-to is different. So that gives me 10,357.34. That is now cubic feet. That is a portion of my volume.
So that's just the lean-to though.
That's just for that's the lean-to plus that section of the building. Yeah. So we still have to do more work. I'm going to call that volume A. That was after we multiplied by the 14. So that's the volume of this portion. Now, while we're here, guys, let's go ahead and figure out the contribution to the surface area of this. For the surface area, we have the come on now. We have the 739.81 times 2 because there's a back wall. Which gives us, what, 1479.62? So that's this wall and the back wall. So for surface area, actually I'm going to move this down a little bit.
So the volume of that cutout is that?
That's the volume of that cutout, yes. We took that area times the length of the lean-to, 14 feet. So I have the 1479.62 square feet is the area of my ends. Now I also have this wall of the lean-to here. Mine is 14 feet by 9. So this is 9 by 14. Whatever yours is will be different again. That's 126 square feet for that. So this will be plus 126 for that. I've got the roof area here, which is also a rectangle. Does that make sense? That rectangle is 14 feet. And this is what we got off of the slope up here, 20.56. We found that length. So 20.56 goes here. So 14 times 20.56 is 287.84. That's the roof of the lean-to. So over here, plus 287.84. Plus, I need the round portion of the roof here. This portion here. That's going to be this arc length times 14 feet. So I still have to find that arc length. So my arc length is going to be the circumference of the circle. Now I'm using my radius of 2.11 times 2 times pi, and then that length will be, what was that, 120.8 degrees. My angle over 360. So my 20.11 times 2 to give me the diameter, times pi, times 120.8 was my angle for that sector, divided by 360. So I have an arc length. That is definitely not right. Is it? That might be. Let me try it again, but it might be right. So 20.11 times 2 times pi times 120.8 divided by 360. Yeah, it looks like it is right, actually. So 42.40 feet is that arc length, and we're going to multiply that times the 14 feet to get an area. So times 14 gives us 593.59. So 593.59 square feet is the contribution of that to that area. I just took that arc length times the 14 feet. That's basically a rectangle. It is 14 feet long, and the length or width is whatever that arc length is.
So 14 feet is the length of your lean-to, right?
That's the length of my lean-to, yes. So your length will be different. I'm going to pause for a minute, let you guys find the arc length and those areas. So what we have so far is we have the volume of this section and the surface area of this section. So if I go back up to my original drawing, I have the volume of this piece right here that's in brown. I have this surface area, this wall, the back side of that. And I have this end wall and the end wall. So all I need for surface area is what wraps around the rest of the roof. Now we're going to come back to that. We need to find that volume as well. And that's going to be the easy part.
Yeah, easy.
So we're finding the area of a segment here. This is a right angle. This is 20 feet and 20 feet. Half of your original base. This for me is 2.11 feet, which is what I had to add on to get my full radius. So the first thing I have to do is I have to find this angle here. Well, we already found this angle, didn't we? That was 6.02, 6.03, 6.02. Which makes this one here 83.98 degrees. That's not really the angle I want. The angle I really want is this whole one across here. 83.98 times 2, 167.96. This is different than any of the angles you found in the last problem. The only angle that's useful is this one here. Otherwise, we could have found that angle by doing the inverse tangent of half my base, which is the 20, divided by what I had to add to make my radius, which is the 2.11, and then multiply that angle by 2 would have given me that. So now that I know that that is that central angle here, I can find the area of the whole sector.
Philip, I don't even have the other one. Are you starting this one?
You can go back through the video later step by step if you have to. So the area of that whole sector is going to be the area of the circle, which is the radius. Remember, this is 20.11. I'll label that in here. Squared times pi times this angle now of 167.96 over 360. So 20.11 times pi times 167.96 divided by 360. I get 29.48 square feet is that area. But from that area, I have to subtract out this triangle. That triangle is 40, right? 20 plus 20 is 40 by the 2.11 divided by 2. So 42.2. That sure ain't right, is it? Oh, I didn't get that squared. This is not my right area, that's why. Let me try that again. $592.76 is my correct area. And 42.2 is what I need to subtract out. So I'm going to subtract out my 42.2 square feet here, which gives me 550.56 square feet. So what I just found there is this area. So I'm going to pause and give you guys a minute to find that area. It's just the area of a segment. Find the angles, find the area. So right there. Okay, so what we found here, guys, we found the area of this segment. Now that is not part of our surface area because we've already included the area of the end walls in our surface area. By the way, on your quiz it asks for the area of the walls. That'd be these two pieces put together, right? The 126 was from this wall here. That's just a rectangle. So these two are part of the roof area. Oops, I can't do it that way, can I? So those two are part of the roof area. So anyway, what we found here is an area of 550.56. We're using this area to find a volume. Now your area will be different. We're going to use this area to find a volume. In our original drawing up here, the whole ridge was 60 feet. We've already used 14 feet of that because of the lean-to. So that means the rest of this must be how long? 46. 60 minus 14. So this piece here is contributing to a piece that is 46 feet long. So I'm taking that area times 46 feet to find the volume of that section. That's the rest of our volume. So that gives me 325.76 cubic feet. That goes on, that 25 goes up here with this one.
Where's that surface area?
I'm not doing any surface area.
Yeah, but I don't know if I have it.
Just let me get the volume finished here. Do you see where this volume's coming from? Okay, so now I have to add that to the volume I had from the original section with the lean-to get a total volume, which is going to be how many cubic feet? I gotta get this out of my way here. 0, 1, 13, 8, 6. So that gives me 35,683.1 cubic feet. That's my total volume, those two pieces together. Now for surface area, I'm going to pause, let you get your total volume right now. So you got your total volume. Now let's look at our areas. Now our area is broken down into two sections. Wall area, we already have. We just got to piece it together. We have over here, the 1479 is this area right here, the end wall, right? We've already found that area. We used it to find our first volume, correct? So you've got that area. 1479.62 square feet. To that, the only other wall we have on this place is this end wall here out on the lean-to, right? In mine, that's 9 by 14. And that's what I found here was the 126. So I add those two together, and what I have is 1605.62 square feet is my wall area. So there's my wall area right there. That's the top two numbers from over here. So all you got to do is just add those two together. For roof area, I need to find this section here, the roof of the lean-to, which we already found. That part was this here, the 287.84. Square feet, plus this piece here, the 593, was from this arc right here. Remember? That arc times the length of our lean-to gave us that portion of the roof. The arc portion on the lean-to. What that 593 was this portion right here. Because we had that arc, this arc here, times the length of the lean-to. Give us that part of the roof. So now to finish off our roof area, we need to know the length of this arc and multiply by the 46 feet. Well, that arc length is going to be pretty simple to find. It's the circumference of the circle. So my radius of 20.11 times 2 to get a diameter times pi gives us the full circumference. So radius times 2 times pi is our circumference. Times our angle of 167.96 over 360. Will give me that arc length. So I get 58.95 feet. And what am I going to do with that?
You have to multiply it by 46.
Perfect. I take that 58.95 foot arc length times the length of my shed without the lean-to, the portion without a lean-to, which is 46 feet. Which I get is 2711.77. Square feet. So all I have to do is add those together. 287.84 plus my 593.59 plus the 2711.77. That gives me my roof area of 3593.2. So that is my total roof area. How you guys feeling? Well, the good news is that is step by step everything you need to know to solve that problem. I'm going to pause the recording here for a few minutes, and then I'm going to make a couple comments on the problem number 2. Okay? Okay, so on this problem, the second problem, I'm doing number 11 from the worksheet. You need to find the roof area is the big thing. Of course, this side, the back side over here is just a rectangle. This side's a rectangle with this hole cut out for the chimney. So really the only trick for the roof area is figuring out how much to take out for the chimney. You guys know how to find the length of this slope. I'm not going to go through that. You know you got to find the height using the half span, find the length of the slope, multiply by 36 times 2 because there's 2 slopes. But now we got to figure out what do we subtract for the chimney. Well, there's something called a slope correction factor. No. A slope correction factor can be found on your framing square. What a slope correction factor is the length of slope per foot of run. If I have a 5-12 slope, this is 5 and this is 12, what's the length of this slope? 13 inches, right? Yeah, that's your 5 squared plus 12 squared. That's why 5-12 slopes are so easy to work with. The slope correction factor is your 13 inches divided by 12. converting it into feet. Just let me finish this. So 13 divided by 12 is 1.0833, rounded to 4 digits usually. What that means is anything on that slope is going to, like, for example, if I had a building, now obviously my slope here isn't 512, it's 812. I'll come back to that. But what I could do, that slope correction factor means if I know my span, let's say this is a 30-foot span, the length of the slope is just going to be 30 times that 1.08. That gives me the length of the whole slope over the top of the building. I'm going to prove to you that that's correct now on this example. So this is an 812 slope here. My slope correction factor, this is 8, this is 12. I've got to find this number here. It'll be the square root of 12 squared plus 8 squared. Is 14.4222. So my slope correction factor is that length divided by 12. So I'm keeping it in my calculator. I'm just going to divide by 12. 1.2019. That's my slope correction factor. So if I take my span of 36 feet times that, I would get my slope distance. In fact, let me do this. That would give me both sides. I'm going to do this. I'm only going to do one side. I'm going to do the 18 feet. I'm going to find the one side slope here. Instead of 36, I'm going to do 18 times 1.2019. So that times 18. 21.6333. So that slope correction factor and my run give me this distance. Now I'm going to prove to you that that is the correct distance. My height here is going to be found by doing 8 over 12 equals h over 18. Cross multiply and divide. H is going to be 12 feet. So now this would be the square root of 18 squared plus 12 squared. Which is going to give me my 21.63333. Because I didn't want to. So there, I can find my slope using that slope correction factor. Why do we need to know that now?
Hey, you got me.
Well, because we have this circle that has a diameter of 28 inches. But it cuts an oval through the roof, right? Yeah. It's 28 inches here, but what it cuts through the roof is going to be longer than that. So let's find the area of the circle. That area is 14 inches squared times pi, correct? The radius, half the diameter is the radius, times pi squared. So 14 squared times pi is 615.75. And that is square inches. But now, I'm measuring the roof in square feet, am I not? So how do I convert square inches into square feet? I divide by not 12. 144 is the conversion. 4.276. So what that means is the area of this circle here is 4.276 square feet. Well, what would be the area of this ellipse down here? Times our slope correction factor. 1.20.
Oh my goodness.
So the area of the ellipse is 5.139. So that's the area of that ellipse that I would have to subtract out. To find the volume of the chimney and the lateral area of the chimney. Not quite yet.
Well, I can't even follow you on the thing because I don't have a span.
On yours for the quiz, I told you 40 for the span, didn't I?
Yeah.
For the quiz, use 40 for the span on your quiz.
Okay.
So I've got this chimney that's 7 feet high, right? So I'm looking at my chimney here. 28 inches. And it's 7 feet tall on the long side, right? I've got to find out how far that rise is on 28 inches. So I have an 8/12 slope. Yep. So 8 times 28 divided by 12. 18 2/3 inches here. No, that's for the whole 28 inches. So what that means is over here, this side is, if I divide that by 12 to make it a foot, I get 1.56 feet. So this height here is 7 minus 1.56. So this is 5.44 feet. To find the volume and the lateral area of this cylinder, of this chimney, I can do this. Cut this off, take this piece, flip it up, put it in there, and I just have a cylinder. What would the height of that cylinder be? I cut off this little point here and I flipped it up, filled in this piece here, and I made a cylinder, just like I did with trapezoids. Remember I did with trapezoids? Average of the bases? So what I'm going to do is stick with me a second, I take the long side of my chimney, I take the short side of my chimney, and I just average them together.
Divided by 2.
Averaging them together is divided by 2 is part of the averaging them, yeah. So what I can do is I can find my volume and my lateral area as though this is just a cylinder who has that 28-inch diameter and whose height is that average height of the two heights, the short height and the long height. The long side and the short side.
So I don't even need to find this. I just need to find the short side.
Find the short side and the long side and average them together. The long side's given. The short side, you got to find out what's the deduction to get to the short side. That'll help you. That'll find the volume. So the volume is just a cylinder with a height of 6.22 and a diameter of 28 inches. So of course the 28 inches you're going to convert into 2.33 feet, right?
Hey, you guys go back to that.
What I did, hold on guys. What I'm doing is I'm looking at this from the side, right? Just like I did with a trapezoid. Remember when we did trapezoids? We cut this piece off and we flipped it up to make that squared off. We cut this off, flipped it up to make a rectangle. I can do the same thing. I can cut this off here and flip it over here and it fills in this piece just perfectly. And the height of this cylinder is the average of the two sides, the long side and the short side.
So the only reason we need to figure out the ellipse is
for the roof area. What to subtract from the roof area. That's all you need to do.
Can you show me how to get the slope conversion thing again?
Slope conversion factor?
Yeah, that one.
Sure. I'm going to pick a random slope. What's the slope on your quiz?
The slope on the quiz is 9/12.
Okay, so let's do a 13/12 slope.
What do you think?
I wanted to make sure I didn't give anybody the slope for their quiz. So on a 13/12 slope, what we have to find is we have to find the length of this hypotenuse, which is the square root of 12 squared plus 13 squared. So that gives us 17.6918. I'm just going to divide that by the 12. gives us 1.4743.
Cool.
That is my slope conversion factor, or slope adjusted factor.
Alright.
Thank you.
That is all. Any other questions?
How do you find the short side?
Yeah, I have another question, but I'll wait till you shut up your recording.